Hello and welcome to another coding session. How about that? How about that? Today I wanted to do the same thing that I did yesterday. I want to continue developing my text editor. Right, so you can find the source code of this text editor in the description, and in a previous episode we actually implemented a very interesting thing. We made the text editor a little bit more dramatic than it initially was. Let me show you, which gave me actually a couple of interesting ideas. So I'm gonna, so I think we already merged everything, right? So I'm gonna check out the master. Prune origin and git merge origin master. So, is it not master? Okay, so there we go. Here is a master. And then I can remove the scroll. So let's rebuild everything. Hello, 715209. Hello, hello. I hope your numbers don't mean anything bad, otherwise I will have to ban you. But welcome to our friendly Twitch channel. So this is basically what we implemented yesterday. So yeah, we have a text editor, which is extremely dramatic, as you can see. Right, so basically we have a camera that follows the cursor, which makes the entire typing experience extremely dramatic. So yeah, and it's kind of cool actually. Hello world. Right, so and then here, and it's also a little bit dizzying, so we're definitely gonna fix that, but yeah. I can also open the source code of the text editor itself. Right, so this is how the source code looks like. What's interesting is that we're not even doing any optimizations, right? We're not like cooling. I think, how does that call cull? The word, you know, C-U-L-L. I keep forgetting how you're supposed to pronounce this word. We're not like removing things that are outside of the screen or stuff like that. We're just rendering everything at once, and it just kind of works. Maybe SDL is doing something special in here, and so yeah, it's kind of interesting. So since once I implemented that, that gave me an interesting idea. What if we continue the topic, the theme, I would even say, of these like dramatic effects in the editor, right? So there will be a lot of like zooming and panning and stuff like that, maybe a little bit of like effects, particles, and so on and so forth. And if we want to continue that theme, I think we'll need to port our renderer from pure SDL to OpenGL, right? So, and that's what I wanted to dedicate today's stream to. I wanted to dedicate this entire stream of like just taking this, you know, renderer and implementing our own renderer in OpenGL. So, yeah, shouldn't be difficult because I implemented similar renderers before. So, yeah, I have a little bit of experience in that. Well, let's go ahead and do that, I suppose. Hello, Draco. Hello, Manasome. Hello, hello. Explosions, yeah, maybe. I think people already did something like that before with like Visual Studio Code, and I think Visual Studio Code kind of uses OpenGL for like WebGL for some cases. I don't know. So, but it's not as dramatic as this stuff, right? So look at this camera movement. I think it's pretty cool. All right. Okay, so let's go ahead and implement that, I suppose. OpenGL renderer. So src. So I think I'm going to start OpenGL renderer in a separate main function. So basically I'm going to comment out the current main function just by renaming it to something that is not main. And I'm going to start another one in here. So it's going to be argc char argv. And we're going to just basically start from scratch. But initializing OpenGL, preparing the you know, vertex buffer objects, the vertex array objects, and so on and so forth. And yeah, so that's basically going to be the drill. Deep Singularity, hello, how are you doing? Hi. Okay, guys. So I think I'm gonna keep using SDL. I'm gonna use SDL as basically OpenGL initializer. We'll see how it goes. So yeah, we're gonna initialize the SDL. To be fair, I don't remember how to use SDL as an OpenGL initializer. Maybe I can steal some code from my game, but the game is written in C++. But I think it shouldn't be that hard to do. So where is main CPP? There we go. Here it is. Yep. So we're just initializing the SDL. We're creating the window, and instead of creating a renderer, right, we set up OpenGL like attributes, and then create the OpenGL context. We also initialize glue for additional extensions and stuff like that, and then prepare like a blend function and so on and so forth. Okay, looks reasonable so far. So maybe this is precisely what we're gonna do in here. So SDL init video, check the code, and then I'm gonna actually create the window, right? So might as well actually copy paste this entire stuff in here. So the next step here is setting the version of OpenGL. So in here we're using OpenGL 3.3. Yeah, so that's basically what we're doing, nothing much to say. So I think I'm gonna actually copy this code in here. We don't need this to do, I suppose. So there's a print ln. This one probably should be something like printf. So GL version d .d major hello land word scammer. Hello, welcome to the stream. So this is the OpenGL version. Okay, so that initialized OpenGL. So then we are creating OpenGL context. Yep. And we also need to initialize glue. So let me actually check if this entire thing still compiles. Right, so I'm gonna be recompiling this thing as I go. So we have unused variables. That's easy to fix. argc, argv. You know what? I have an idea. What if we have a special macro, something like OpenGL renderer, and if the OpenGL renderer is defined, right, we're including that main, otherwise we're including the old one, right? So this is where we're gonna actually put and if OpenGL renderer. There we go. So, and switching between like these renders is going to be as easy as commenting and uncommenting this entire thing. Alright, so let me, and of course in that case it would make sense to actually call it main. Right, so we have two mains, but you switch between the mains depending on which macro is available. Right, okay, so and in here we initialized OpenGL context and the GL version turned out to be 3.3. Alright, makes sense. So the next thing we need to do, we need to initialize the glue, right? So as far as I know, glue is like an extension wrangler or something like that. Yeah. So extension loading library. I'm not sure why exactly we need that, because SDL, I think SDL is capable of loading its own extensions, right? SDL2 load extension. Not quite sure why we have to use glue. Right, so SDL, this kind of stuff, extension, hello XT Cello, welcome to the stream. SDL extension, no, this is not already what I mean. But okay, so I'm gonna just accept. So basically glue is for some reason needed on... Oh no, it's not only needed on Windows, we also use some of the extensions provided by glue. So maybe it's not needed. Load OpenGL extensions. There should be something like that. Yeah, OpenGL extensions with the SDL. Checking extensions loading with SDL. So when you're sure that an extension is an OpenGL implementation, you need to load it. With SDL, the key is using getProg. Oh, well, that means you have to do a lot of things yourself, essentially. Yeah, you have to do a lot of things yourself. With glue, you don't really have to do that yourself, which is nice. All right. So let's go ahead and just try to compile it. Dirk Tulhu, hello. So, and in here, we need to include some other stuff. Something CPP, right? Something CPP. Yeah. All right. Let's include this entire thing. Maybe it's gonna be useful. Yep. So we don't have a panic. Okay. So to emulate the panic, we're gonna print all of that to the standard error and then exit with 1. All right. Okay, so, and we don't have a glue init because we need to actually link everything appropriately. So let me take a look at the build.sh. How do we link everything? So we're just adding glue to the packages. Okay, that makes sense. All right. Do I even have a packages variable? I don't have a packages variable, so I'll have to introduce it. So it's DL2 and then glue, and this one is basically the packages. All right. And let's try to rebuild everything, and everything is rebuilt. Could not initialize glue? The fuck? Really? Couldn't initialize glue? That's unbearable, actually. What the fuck? Why wouldn't be able to initialize the glue? Okay, so let me try to compare the code that we have in there. Right. Glue init. So we created the context, I'm pretty sure. Maybe I'm just missing something. But yet again, it could be something that I didn't include or something. Right, so if I just print this thing in here, right, I'm printing this thing in here. No, it's actually fine. Huh. Yeah, it's always like that with glue. Every time I try to use it, it's just like unclear what the hell is going on with it. So for some reason, it's always difficult to get it working at first. So there's also an OpenGL template that I use from time to time if anyone is interested, so I can actually maybe take some code from there. So my OpenGL template. There we go. So can I get some code from there? So we're using GLFW in there. Glue init. Yeah, it's totally fine. Could not initialize glue. But at the same time, I can do that in that game, right? So if I take a look at the game from where I'm stealing all of that, right? So something like this. Yeah, so everything is initialized correctly. And if I even take a look at this kind of stuff, so it's gonna be main, cpp, glue init. There's something small, yet again, that I'm missing. Shit like that always drives me nuts. Like, why don't you want to initialize? Is it because I put the logic incorrectly, or did I not include something? We can try to step debug this entire through this entire thing, and why not? Just to see, maybe that will help. So if I just try to run it, yeah, it doesn't work. So let's do GDB, let's break on main, and let's just run this entire thing to enable. Right, so then we create the window has been created, we set the attributes, then we set the entire thing, we create this kind of thing, and yeah, try to call glue. Can we step into this thing? We couldn't even step into this thing, and it just like didn't initialize properly. Let's try to Google up. Glue could not initialize. Glue isn't initializing. Okay, so this is apparently a pretty common situation. So unfortunately the glue source code is available so we can check. The main reason why we'll fail to initialize if there is no OpenGL context when you call... Oh, there's no OpenGL context. Wait a second. Okay, so is this because this operation has failed? Yeah, I just realized that I didn't check for a failure for... Okay, so this is actually like probably a clue. It can in fact fail. Oh, you have to get that context and set... Wait, this is really strange. Did I copy-paste this thing incorrectly? It feels like I copy-pasted incorrectly. So, main CPP, right, main... where's the context? You create the context, but we never actually set that context. That is actually really strange. Delete and then you delete the context. That's really strange. Create an OpenGL context and make it current. Yeah, that's precisely what needs to happen. Returns the OpenGL or null. And okay, so maybe that's precisely what we need to do in here. So we do SCP. Right, I'm gonna wrap it with SCP, and SCP is effectively going to check the pointer before returning it back. Right. So there's probably something wrong in there. All right. The specified. Holy freaking shit! I forgot to add a flag OpenGL for this window. I could do hello. Why do I always have some stupid problems when trying to work with OpenGL? No matter for how long I work with OpenGL, there's always one small thingy that just like, yes, okay. Okay. Alright, I completely forgot about that. Like, you forget one little thing, and your program just silently just doesn't work, right? Well, I mean, in this case, I just forgot to also handle the errors and stuff like that, but I mean, yeah, it's kind of painful to work with, to be fair. OpenGL was always kind of painful to work with. So let me quickly grab for this function and see what kind of flags we can get in there. Kind of flags. Okay, so here's the flags, and full screen, resizable. OpenGL, there we go. All right, so let me see. Make -b. And yeah, it worked finally. Holy shit. So I just forgot a single flag. You forget a single flag and there you go. You'll spend shit ton of time trying to figure out what the hell has happened. So we created the context, we initialized this entire thing. Do we need instance drawing? I don't know yet. We'll see. The winner gets T, that's for sure. So then we need to enable the blending because we want to be able to have alpha, and this is the function that we're going to use for the alpha. So also debug output. Yeah, debug output is actually a very useful extension. I think I'm going to use that. Right, so I'm going to quickly check if this extension exists. And if it doesn't exist, maybe we should print something like to std error warning. GL debug, maybe debug output extension is not available. This thing is not available. So, but we're not going to crash the entire thing. And we also have a message callback that I stole from the internet at some point. So I'm going to also copy paste it in there just in case. Yep. So here it is. And let's see. We're also gonna rebuild this entire thing, right? Alrighty. So was it available? I think everything was available in here. I guess that is it. yeah, that's pretty much it for initializing the OpenGL context, as far as I know. So now we need to create, we need to create basically the renderer, right? So we need to create the renderer for the font, for our font. We're gonna upload the font as a texture on the GPU, and then we're gonna have Vertex and Fragment Shader to actually accept a buffer with characters. It will take the buffer with these characters and then look them up in the sprite sheet and actually render them in the triangles and whatnot, right? So this is basically what we're gonna do. But first, before we go into that, I think we need to create like a simple, like at least triangle, at least the rainbow triangle thing, if you know what I'm talking about, right? So we need to be able to compile the shaders, link the shaders, and just use them to render things. That's what we at least need to have, I think. Let's go ahead and do that. So maybe I can steal some of the code from my OpenGL template. So yeah, I think it sounds like a good idea, because we already have some stuff for compiling shaders in there. And furthermore, so we also need to be able to read the shaders from a particular file, unless we want to actually bake the shaders into the source code, but unfortunately C doesn't easily allow you to do that, unless you like write like a meta program that basically takes a particular file and turns it into a string, right? If you So you can even use something like XDD, right? So as far as I know, XDD is actually pretty... XXD, it's not XDD, it's XXD. So I think it has... include, so it can take any file and turn it into C code that you can just include, right? So imagine that you have a shader, like, you know, I don't even know, like font vert, right? So this is going to be Vertex Shader. So version, I suppose, is going to be something like this. And then we're going to have like a main function in here. So here's the main function. All right, and if you try to do something like XXD, was it I? I think it was I. Yeah, I already forgot what it was. Yeah, it was just I, like a small I. There we go. It generates the C code of bytes, which you can just simply include in your project. But that means that your source code, that your build depends on XXD, which might not be available on other operating systems and stuff like that. But there's good news. XXD is actually available as a single source code file that you can just include into your project. And to be fair, I'm not sure if it's worth including the entire thing, because it's kind of big, and the functionality that you need from XXD is actually can be implemented like easily yourself. You can just implement this kind of stuff yourself. But on top of that, you won't be able to reload the shaders if you want to, right? So maybe this is something that you want to have while developing the text editor. So yeah. There's always trades-off in here. Always different kind of trades-off. So yeah, well, let's actually implement the one that hot reloads everything. So we're gonna have a slurper file, but I'm not sure where I'm gonna put that. So here's the... I'm gonna create a separate translation unit for this kind of stuff. So let's include file.h and file.h. All right. Slurping the file. Actually slurping the file. I really apologize for being super sleepy right now. Before the stream, I actually ate a huge bowl of oatmeal, and I really want to sleep right now. I don't know why I did that. Well, I know why I did that. I was actually hungry, but I, you know, overestimated my abilities of how much I can eat, and now I just ate too much. So yeah, that's my problem here. Anyways, so this entire thing will basically crash if it cannot open this kind of stuff. All right. So I don't think it will help. Coffee never really helps me if I'm completely like full, right? It's just like, I mean, I don't really drink coffee anymore. So maybe some tea. I could probably make some tea, but I'm gonna make it a little bit later. I'm gonna make all of that a little bit later. So the next thing I want to be able to have, I want to be able to compile the shaders, right? Given the shader source and so on and so forth, I want to be able to do that. So we have a raid from Pilada. Hello, welcome. Thank you so much for the raid. How was your stream? Was it good? Was it Gucci? Thank you so much for the raid. All right, so we're doing a little bit of a OpenGL in here, so so we need to compile the shader. We need to compile the shader source. So I'm gonna just like take this entire thing in here. So also maybe it would make sense for me to actually create a special unit, something like glextra.h, where I'm going to put extra stuff for the OpenGL. If not defined, glextra.h, right? So this one's going to be define, and this one is going to be end if, right? So this is basically where I want to keep some of these functions like compile shader source, compile shader file, and whatnot, right? So compile shader file, link program, so looks good to me. I didn't want to say that. glextra.c. Oh, and on top of that, it's actually extremely hot in here right now. So yeah, I ate too much, and also it's super hot. Well, it's not that hot. Maybe I could make a cup of tea, though. I don't know. It's kind of, yeah. Compile shader source. All right. So let's include all of that into the build, glextra.c. There we go. So let's rebuild this entire thing. Is it gonna build? Is it gonna build now? Hopefully, we'll see. So this one requires stdio. Right. It takes too much time to actually compile. I'm actually quite surprised. Why does it take so much time to compile? Is it because of the STB? Probably because of the STB. So str error and maybe error no. Hello, pale. Thank you for saying hi in the chat. I really appreciate it. All right, so exit also needs std leap. So, and then here we need to std boolean actually. Right, we need std boolean. Oh, and this one probably also requires OpenGL stuff. So let me see. So the UGL, yeah, probably we have to do something like this. Is that what you want from me? Holy shit, it takes so much time to compile. What the hell is going on? Seriously. I'm actually quite surprised. It's probably because of the STB. It's probably because of the STB. Okay. But it wasn't compiling that long before. Oh, it also includes like a single linking stage as well. Yeah. So it's probably because it's trying to link with more libraries than before. So that explains it kind of. So this is the file. So free stdlib. Okay, so finally it's compiling. So I suppose we have everything to compile a shader, so we can compile a shader file. Right, and then we can link the final program. And then just use this the final program. Okay, so that sounds nice. So we need to come up with some shader to test things out. Right. So where are we gonna keep our shaders? I suppose we're gonna keep them somewhere here. Shaders. I wanted to create a folder shaders. Shaders. There we go. So this is gonna be font vert. So version is gonna be 3.0.0. So I don't quite remember, so I think I'm gonna steal some code from my game. Assets, shaders, vertex shader, triangle camera. Okay, so we're using 3 core, right? And we're taking the position as well. All right, so that's nice. That's nice. Okay, so what we want to render in here? I suppose for now we can just render a quad. Right, so we can just simply render a quad of a solid color just to test things out. So I suppose we're going to base that on the GL Vertex ID. Jiang, thank you so much for tier 1 subscription for 25 months. My God. Thank you. It's more than 2 years. I really appreciate it. Thank you. How are you doing? Welcome to the stream. So we need to find GL Vertex ID. GL Vertex ID. So this is what we're going to be using. Essentially, this is like an old trick that I suppose a lot of people who do OpenGL know. Is just I'm going to render 4 vertices in a strip mode, right? And the 4 vertices, right? So you're trying to render 4 vertices. You don't know their position, but as you try to render them on a shader, they're going to be numbered 0, 1, 2, 3 in GL Vertex ID, right? So inside of the shader, you can look at the GL Vertex ID and know precisely the number of the vertex you're currently rendering. So you can take this number 0, 1, 2, 3 and represent this thing in binary, right? If you represent it in binary, it's going to look like 0, 0, 0, 1, 1, 0, 1, 1. If you take these binary representations and basically draw them as coordinates, as points, oh my God, what the hell has happened? Right, so first point is 0, 0, then 0, 1, right? So this is the second point, 0, 1, 1, 0, this is the third point, yeah, so basically 2, and 1, 1 is this. So they basically form this kind of Z, right? Or N, right? It's more of an N, but it's like Z on the side, essentially. So if you feed that into the GL triangle strip, it will render 2 triangles like that, and you will automatically get a quad without even creating any virtual like vertex buffer objects or anything like that. So basically, you just create a shader that looks at the GL Vertex ID, and based on that ID generates vertices, and you just tell OpenGL, draw me 4 vertices. So that way you don't need to send any data just to like render this kind of like simple quad. So I like this approach. It's not particularly useful in real-world applications, right? Because in real-world applications, you do want to create all of these buffers and put some data into those buffers. But I like this approaches because it's very simple, right? So you want to test things out. You don't have to create any buffers or send any data to the GPU just to test, just to get something on the screen. You see what I'm talking about? Like, you just don't need to do that. So that's why I like it, because it's so simple. So that's precisely what we're gonna I suppose implement right now. Right. So we need to set GL position to the corresponding coordinate. So we have a GL vertex ID, right? Right, and we need to convert that GL vertex ID into GL position. So to extract essentially lower bit in here, we need to do AND1. So this entire thing becomes sort of like X coordinate. And then to get the second bit, we essentially have to do the same thing, but we have to shift this entire stuff to the right. There we go. So we extracted the first bit and we extracted the second bit. And these two bits became the coordinates. Right, but the coordinates are not integers, they're floats. So the next thing we want to do, we want to convert this entire thing into a float. Right, there we go. So this is a float, and this entire thing is a float. Okay. But here's the thing, this gives you coordinates from 0 to 1. But the normalized device coordinates in OpenGL are from -1, 1, -1, 1. Right, so in here you'll get just like a quad in like a top right place in the screen, which is kind of eh. So one of the things we want to do, we want to maybe move it to the center, right? Maybe move it to the center. And one of the things we can do essentially is subtract 0.5, I suppose, right? So we can do something like vec2 xy. Can I just subtract 0.5 without creating a new vector? And wonder if this just works. We're about to find out, but if it doesn't work, we can always just do something like vec2 and just duplicate it like that, or maybe even like that, I don't know. But I want to try this kind of stuff first and see if it's gonna work or not. So that's how we can generate the vertices, 4 vertices. So the next thing is going to be font frag, right? So this is going to be a fragment shader. Version 3.3 core, void main, something like this, and we need to set GL frag color. So essentially we're not going to try to do anything fancy in here, we're just going to set the color to red, right? So since we just want to test things out, right, I'm gonna set it to red. Alright, that's pretty much it. That's pretty much it. So let's go back to the main.c. And here, after we initialize everything, right, the first thing I want to do, for some reason there's something strange with my mouse. It keeps drifting for some reason, I don't know why. So gl extra.h, and I need to compile the shader program. So Tokyo Egyptian mouse. Yeah, that's what it is. Shaders font vert, gl vertex shader, deja vu. I don't remember the rest of the song. I'm sorry. Gl int vert shader. So this is what we're gonna have in here, a vert shader. Pointer to vert shader. If this entire thing failed to compile, I suppose we're gonna just exit with 1 for now at least, right? So, and I'm going to compile 2 of the shaders. So this is gonna be vert, this one is gonna be frag. There we go, we compiled a vert and frag, and let's see if we didn't do any significant fucky-wacky by actually running the entire shader. Right, so we need to include like GL extra. GL extra. Alright, so Fragix. What the hell is Fragix? There's Vertex Shader and there is also Fragix Shader. Fragment Shader, that's what I wanted to type, Fragment. Vertex and Fragix. Have you guys heard about Fragix? Fragix Shader. Nice one. Alright, so if I try to run the thing, Vertex Shader. Fragment Shader. Okay, so it failed because too many parameters to vec2 constructor. So it failed in Vertex Shader though, first. Right, at the position of 6. Oh, this one, I know why precisely it failed, because it has to be constructed like this, vec. Well, because of that, we might as well just do something like x, y, 0, 1. So the thing about geoposition is that it's actually 4-dimensional vector, right? So it's 4-dimensional one. And this entire thing exited abnormally, but it didn't tell me why. Right, so I would expect this entire thing at least tell me the error, what exactly happened. Right, so let me double check. So compile shader file. Doesn't it compile a shader file actually do things? Right, so we compile shader source. Oh, wait a second. Oh, it has to be not. I see, it has to be not. And of course we need to recompile this entire stuff, right? So we're just recompiling. Not. Okay, so too many parameters to the vector. Okay, so this failed in Fragment Shader, right? So 4. Oh yeah, of course it has to be 4. There we go. So, but that's the way I didn't really have to do this kind of thing. There we go. So we managed to compile all of the shaders. There we go. Here are those people. And again, hello, La Chong. Welcome to the stream. So next thing is this. We need to link the program, I suppose, right? So gl uint program, right? So gl uint program, and we'll have to provide it in here. If not, I'm gonna instantly exit with 1. There we go. So the next thing I need to do, I need to just use this program, if I remember correctly. gl use program, and there we go. We're effectively using this program already. I need to keep recompiling these things. Just a second. Maybe I should really make a cup of tea. Passing argument. Oh yeah, you have to pass it by a pointer. Pass it by a pointer. Okay. So now we need to organize the event loop, right? So we're going to have a boolean false, right? And while not quit, we're gonna pull all of the events, SDL event, while SDL pull event, like this. If you encounter the event type quit, all of that is classic, I would even say. Rule W. SDL quit, and this one is basically quit equal true. There we go, there we go. So that should create the event loop, right? This should create a window. I think it's still compiling. Holy shit. Okay, and it created a window, but it doesn't render anything. So the first thing we need to do, we need to clean that window. So gl clear color, right? And what's going to be the clear color? Let's set the clear color to black for now, right? Then we do gl clear, gl color buffer bit, I think. 2. And I forgot to swap the buffers. Yes, I forgot to swap the buffers. SDL gl swap buffers. Swap window. 2. Thick stacks? What are you talking about? I don't have any thick stacks. I don't even know if it's better or good. So. Okay, so there we go. We can try to put some different colors in here. How does i3 knows to put window in a floating mode? It doesn't. Every time I start a window, I actually quickly put it into floating mode myself. Look, look, look. So if I just start it and do nothing, it's gonna be embedded into the tabs. Right. So, but I usually do it like this. Look, look, look. This is my usual workflow. It's just like, and I quickly just put it into the floating mode just to test things around. So yeah, it's just the magic tricks. It's just the magic tricks. That's what it is. Why C when assembly exists? C is more portable, by the way, than assembly. C, if you write your application in C, it will work only on a single architecture, probably on a single operating system. But if you write things in C, it potentially will work in pretty much any environment, actually. Depending on what kind of standard of C you depend, actually. I think you can also set a 3 to automatically make window floating based on the title or something. That's actually a pretty good idea. I need to think about that. So I noticed that people who suggest use assembly instead of C never actually thought what using assembly means, or maybe they never actually programmed in assembly. And that's probably why they're suggesting it, because for them it's like a black magic, scary voodoo that you should never program in. That's why they're, you know, suggesting this kind of thing. Which makes sense to me, right? Which makes sense to me, sure. So, seems good, seems good. Now, 2 seems to be working. So now I need to actually invoke draw array, right? So let's take a look at the docs.jl. Will you add some fonts renderer? It's kind of difficult to develop, you know, text editor without rendering fonts. I don't even know how you do that, but I mean, maybe you can do that. I'm not a really good developer to know this kind of stuff. So, GL draw arrays. So let's actually quickly draw them. So what's going to be the mode in our case? GL triangle strip. Is it just a single triangle strip? Yeah, I think it's a single triangle strip. So the first one is going to be 0, and the amount of things you want to render, the amount of vertices, is actually 4, precisely as I said. Right, and let's see what's going to happen. Triangle strip. And it didn't work! Luckily... Oh yeah, okay. Fuck! In a OpenGL 3, you can't just... You don't have a default VIO. For fuck's sake. Why don't you have a default VIO like in OpenGL 2? It was so... In OpenGL 2, it was super convenient. It's kind of interesting how the higher the version of OpenGL, the less convenient it becomes. Right. What is Val? It's a vertex array object. It's a basically combination of all of the vertex attributes that go into the shader. But since we don't send any vertex attributes into the shader, we don't really need a VIO, but we still need it, so we just need to create an empty VIO. I think GL again, vertex arrays. Yeah, this is basically what we need to do. So we need to create only one VIO. Alright, so this is gonna be only one. GL uint VIO. Alright, so and this one is gonna be something like VIO. Yep. And I think I should use it afterwards. Yeah, I have to bind it. GL bind vertex array. Alright. GL bind vertex array. So it's gonna be VIO. Okay, so here is the thing that we managed to render in here. Isn't that cool? Isn't that cool? I think it's pretty cool. So inside of the shader, inside of the fragment shader, we can change the color of the quad, right? We can change the color, so now I can make it green. I should have not actually rebuilt the whole application because I can just restart the whole thing. Right. And we can actually render different fragments depending on their coordinates if we have glfrag chord. Right, but glfrag chord, you have to normalize it, right? So you need to know the resolution of this entire thing. What's going to be the resolution? Well, we can always just take xy and divide it by, I don't know, vector 2, 8, 6, right? And here we can just set it to uv, right? And depending on these uv coordinates, so this is going to be uv y, maybe that will, yeah, there we go. So we have something like this. We can even make it like slightly smaller, maybe half of this entire stuff. So this is going to be like 300, right? So this is 300, and that didn't work, probably because I have to make it twice as big. I don't quite remember. Yeah, I think it has to be twice as big. Yeah. So you have to put an actual like resolution of this thing in there, but whatever. So yeah, everything seems to be working, everything seems to be twerking. We have VIOs and so on and so forth. Interestingly enough, we're rendering everything right now in a normalized device coordinate, and normalized device coordinates are -1, 1, -1, 1, right? Which is not particularly convenient. We want to be able to render this kind of stuff in actual screen coordinates. Joe, you guys don't know what Joe? I can show you, I think. I cannot, but I can install Joe. Just a second. I think I deleted it. I don't know why I deleted it. Yeah, so here's Joe. Let's install some Joe. It's just reading database, just give it some time. I don't know why it takes so much time. Unpacking Joe, setting up Joe. And there we go. All right. So, and for those who doesn't know, it's a text editor. I already had a file mama in my home folder that already had something. That means I already made that joke. Okay, so it's a very old joke. Yeah, Joe is a text editor. And this kind of stuff actually makes it possible for you in the terminal to put Jomama, and that is a valid bash command. Yes, Jomama is a valid bash Linux command. It is working. So I can also put something like, I don't know, force and head. Can I say this kind of shit? Yeah. So now I want to be able to map the I want to be able to actually render quads in screen coordinates. To do that, we'll have to. Oh boy. I need to be able to send some information into the shader, right? Some information about what exactly I want to render in there. Exactly, I want to render in there. Install it now. I can create it to Beam trap. Yeah. So I can show you how to exit Jomama. Look, hold key K, right? Well, I mean, it literally freaking tells you how to... I'm not gonna even answer that question. Jesus Christ. I swear to God, people. Anyway, so I think I want to make a small break. I need to make a cup of tea, and after the break, we're gonna continue, implementing the OpenGL renderer. It's gonna be fun. Trust me. Alright, so we need to think what we need to do next. I think the next thing I want to do, I want to actually load the font sprite sheet as the texture, right? So that's the thing I want to do in here. So we have a font sprite sheet. Where is it actually? Here it is. So yeah, that's basically what we need to load into the texture. The thing is, loading texture is pretty tedious process, so I'm probably gonna steal some code from my existing game as well. So something like font cpp. So we initialize, but it doesn't really. So there is it's probably somewhere in a texture, right? Yeah, there we go. So you first need to set up the active unit, right? So then you need to generate the texture, then bind the texture, set some parameters in there. Luckily for us, we can just use the nearest interpolation because it's a like bitmap font. It's actually very pixelated, and then we just need to send this kind of stuff into the texture. Do we need to generate mipmaps? I'm not quite sure. All right, so let's go over. So this is going to be main cpp. Here is the vertex. So I think I'm going to actually move everything sort of like related to program initialization to a separate function, maybe. Void init shaders, right? So here we're not accepting anything. Maybe not. Actually, don't want to do that because it's like it will make it more difficult to read than needed. So because of that, I'm gonna just like put internal void. Classic. It's like when you watch any Handmade Hero streams, infinite internal void. Cheers, by the way. Internal void. Okay, initialize shaders. Sadge indeed. Chat, don't be sadge, be okayge. Init texture. Right, init texture. So first we activate the texture unit, right? So I suppose we want to use something like texture 0, right? So after that we generate the textures, right? We want to generate only a single one, so that means we're gonna have something like gel uint font texture. Maybe I'm gonna put it in here, and font texture, there we go. And then we bind that texture. GL texture to D, font texture, there we go. So we're going to be using the nearest interpolation for literally everything. I wonder if I can just use nearest for both of them. I don't quite remember if I could. I'm gonna try to set it like this and see if it's gonna crash or something. We're gonna clamp everything to the edge. Why not? I didn't see any problems with that. And now, oh man, this one is gonna be rather interesting. Oh yeah, we need to also load the data for the texture. Yeah, we need to load the data. Right, so we have a special thing in here for loading shit, I suppose, but I don't think I'm gonna be using that. So I'm initializing the font texture. So in the first thing we want to do, we want to call STBI. Right. So one font C, STBI. So where is the STBI call? STBI load, it's a SDL extra, okay. So that's essentially what we want to do in here. Yep. So it's going to be width and height, and this is the pixels that we've got. If we didn't manage to do anything, we're going to basically crash. Okay. So the next thing we need to do, we need to call this function glTextImage2D. So it's gonna be something like this. Okay. So target, if I remember correctly, has to be glTexture2D. Right, so let's actually set it like this. glTexture2D. Level is basically needed for manual MIP mapping. Yeah, there we go. So through the levels, you basically set different MIP maps, right? If you don't want to rely on the MIP map generation of OpenGL, you can just use this thing to set different things. Right. So this one is going to be 0 if you don't want to do anything here. In term form, I specify the number of cores component in the texture. 1, 2, or 3. Okay, so I suppose 1, 2, 3, or 4. So following symbolic context. I suppose I want to like use 4, right? I don't see any problems with here, but I think there's a constant GL RGBA specifically for that. So then we have width, and then we have height. The border is kind of weird. I never understood the meaning of the border, but I'm gonna set it to 0. GL texture image 2D, right? So here's the border. Right, border format. Suppose it's going to be also GLRGBA. GLRGBA. The type unsigned int, I suppose. GL. It depends on which one. Yeah. It's for the single component, right? Yeah. So we're going to use that one. So in the data is going to be the pixels. Hello SP Cafe. Welcome to the stream. There we go. We're not going to try to generate MIP maps, and I think that is it. Hopefully that didn't create any problems, and let's just go ahead and try to do something. So the actual thing we're loading in here is this file. All right, so I'm going to put it in here. So here's the file, and let's recompile this entire stuff. Thanks for the welcome. You're welcome. Okay, so this is the file path. Maybe we want to actually save the file path in here. I'm a very, very engaging streamer, and I acknowledge each individual message in the chat. And I welcome everyone into my stream. Yes. Okay, so here's the pixels, and there we go. Reading chat, yes, exactly, exactly. I'm always reading chat. I'm always reading chat. I read every message. Okay. So now we maybe want to actually try to render the sprite sheet. Right, so we can try to actually render the sprite sheet. So let's go to the fragment shader, right? And as far as I know, the texture is a simpler 2D, right? Yeah, there we go. So this is the texture. So I think I'm gonna call it a font. Right? So this is gonna be the font. And how can we render the texture? We need to know the texture UV coordinates, which means that we need to pass those UV coordinates from the vertex shader. Vertex shader generates the vertices. It can also generate UV coordinates. UV coordinates are usually from 0 to 1, right? So essentially, you have some sort of a quad in here. For which you want to generate a texture, and the coordinates of the textiles are going to be from 0 to 1, 0 to 1, right? So that's precisely what we need to generate in here. So, and if you take a look at the vertex shader, if you remember explanation of this trick that I used, it already kind of generates the coordinates from 0 to 1 and 0 to 1, right? So the only thing we're doing here, we're actually shifting it around, right? So we're shifting it around. Maybe one of the things we can do in here, we can output UV coordinates, right? So this thing will basically go into the fragment shader, and this one is going to be basically UV, right? So X and Y, there we go. So now the fragment shader should know the UV coordinates, and here we can say we accept the UV coordinates. There we go. That's how easy it is. So after that, I can probably try to run this entire thing just to see if I did a fucky-wacky. Apparently, I did in fact make a fucky-wacky. Image sample variables may only be declared as function parameter or uniform. Oh, yeah. Thank you so much. Uniform. It has to be a uniform. Yes. Yes. Fucky-wacky indeed. Oopsie-doopsie. Uvu. That's precisely what we did. A little bit of a fucky-wacky, and a tiny bit of oopsie doopsie. Ralph, hello, how are you? So let's continue. UV and yeah, so now we know UV coordinates. I don't remember, I think GLSL has a function called texture, right? So it literally has a texture. And yeah, it accepts this sampler and UV coordinate. So that means I can do the following thing. I don't even need these UV coordinates, by the way. Oh, this is actually pretty cool. So if I use these UV coordinates, it's going to be even cooler. Yeah, there we go. So it's a little bit more bright now. Can we just do sign on them? I think we should be able to do sign on them. ASCII textures for the win. Yes. Sure. Oh, I'm sorry. Can I just multiply this stuff by 2 to make it like... Yeah, look at that. That's actually kind of cool. So, and we can do cosine, so they sort of desync a little bit. And this one is going to be sine. This has nothing to do with actually implementing the text editor. I'm just playing with the shaders. I don't know why I'm just playing with the shaders, I'm sorry. I just feel like playing with shaders. So what I need to do in here is essentially texture, font UV, and there we go, we got the texture. So that's basically what I need to do. So, but I mean, it's like upside down, right? What we need to do, we probably need to invert UV coordinates somehow. So maybe construct a new ones, where UV is going to be maybe like 1 minus UVY. Right, is it going to work? And it worked. Would you look at that? Isn't that amazing? I think it's goddamn amazing. So, and you still can actually multiply this kind of thing with like random interesting colors, right? You can do something like vector 4 and just multiply this entire stuff by a red color and you will get the red texture. Shaders are fun. And you can also as well use UV coordinates yet again in here. Right, and you have like a color thingy. And yep, you can put sign on this entire thing as well. Right, so, and then multiply it by 2. Yep. And maybe that one could be cosine. Right, you see, you basically compose these ideas, right? So we had just colors and stuff like that and texture separately. Who said you can compose that? You just composed it, right? So that's the beauty of this kind of stuff. It's actually super fun once you like wrap your head around it. It is super fun to play with. Right, and what's interesting is that you can probably pass the time in here, right? You can easily pass the time and just add the time like this, but you'll have to pass the time as a uniform. We don't have a uniform right now. So we can quickly do that. So uniform float time, and time is going to be in seconds, right? Design beautiful shaders from scratch. I'm not that good at, you know, shader art, to be fair. So somebody like, I don't know, Provet or Freya, they way better shaders than me. Before, when you had the font renderer with SDL, you could... Yes! Well, I mean, I technically could. I technically could take the pixels of the glyphs and on CPU, pixel by pixel, do all of this coloring. But that would be slow, right? So I still can kind of do that, but that would be slow. Here it's instantaneous, right? So GPU just like generates the shit for me. And we can even try to animate it on GPU. So yeah, let's actually do something like GL uniform or something. Docs.gl. ShaderToy has some really insane shaders. Well, yeah, that's pretty cool. So because ShaderToy is used by like professional computer graphics people and demo singers who basically spend their entire life doing this kind of stuff. So of course they're going to be insane, right? So because it's basically state of art of the knowledge of computer graphics. So GL uniform location, right? So we need to get the uniform location. Get uniform location. You would compute all the colors on CPU and set it to the GPU to draw, but your computing and drawing on GPU. Yes, precisely. That's precisely what I'm doing. Right, on the GPU, so this entire thing is running on the GPU. And this is where I'm just on GPU, knowing where to get the pixel, and also calculate sine and cosine and all of that on GPU. So all these calculations is on GPU. So the cool thing is that GPU has a lot of small cores, right? A lot of small cores, and it's when it's rendering the fragments, like basically like pieces of the thing that it needs to render, it can actually allocate like 1 core per rendering of these fragments. So basically, this program is run like maybe thousands of times simultaneously just to render everything quickly. So that's why you cannot really access like the values generated by neighboring fragments, right? So that's because, you know, you will lose like parallelism or something, but I'm not really proficient in computer graphics, so very sorry. Probably saying some bullshit. Let me see. I want you to actually pass the time, right? So somehow, to pass the time, I need to get the uniform location of the time. So, font texture, initialize shaders. Maybe this is precisely where we're going to be using all of that. So, we're going to use the program. So here's the program. And the name is going to be something like time. Time uniform. There we go. Here's the time uniform. But because of that, we actually have to know this thing up there. 20, and we're gonna assign it graphic GPU unit. Yes. GL uniform. And to set the value of uniform, we have to use this function. Come on, man. Sorry. Yeah. So we're gonna be doing that on each iteration of the event loop or whatever. Okay. Time uniform, and the value is gonna be basically in seconds. We could get the ticks. All right. If you get the ticks, you probably wanna visit the doctor. Anyway, so ticks is actually milliseconds, so that means I need to divide it by 1000, right? So, haha, I'm sorry. It's actually a really important topic for me, because I live in a place where there's shit ton of ticks, and it's just like, especially summer, and especially if it's a hot summer, right? They become especially active. You have to be super careful. It's almost like living in Australia. Luckily, they can't hurt you during the winter. So, imagine ticks at winter. Yeah. All right. So. So do I actually use the time? I don't think I use the time. So here is the fragment shader, here's the time, and cool. Now I'm gonna go ahead and run this entire thing. And yeah, it's working, as you can see. It's working actually in a kind of weird way, but it's still working. Yeah. So let me see. So it's gonna be font fragment, sine, cosine. Maybe I should do something like this, right? Oh yeah, now it's a little bit better. But there's also like this black phase, which is kind of sus, not gonna lie. So maybe you want to offset some of these things by like 25 or something. Oh, to be fair, sine is actually from -1 to 1, so that means I need to add 1 and divide it by 2. So I forgot to do that, right? So that's quite important. So +1 divided by 2, There we go. So that should look a little bit better, hopefully. Yeah, now it won't have as much of a like dark phase as it did before. Yep. So that's basically what we have in here. Where's our gaming text? Sure. Alrighty. Okay. So now we have like everything to render the text, I suppose, right? So we have everything to render the text. How are we going to be rendering the text? We're probably going to be using like instanced rendering, I think. I think we should use the instanced rendering for this kind of stuff. For the instanced rendering, sign. Let me see. To be fair, shouldn't be that hard. So we need to send a lot of information to the GPU, right? So let me see what kind of information we'll have to send. If we're going to be rendering this thing like in here, maybe we could probably render it as a tile or something. This is rather interesting, right? But in any case, if we're gonna render the characters as basically quads with the texture, right, with a particular texture, like so, we need to send, what kind of information do we need to send in there, right? What kind of information do we need to send? We probably need to send the position where this entire thing begins, right? So this is going to be the position. So our font has like a particular ratio of size, like ratio between width and height. So we only need like a single value for the scale, right? So we need to send the scale. So then we also need to send the character that we want to render, right? So we need to send the character. On top of that, we can send, for instance, I don't know, maybe additional color to render this entire thing, additional color. But at the same time, I also want you to have maybe some interesting effects with the color, right? With the gradients and stuff like that. And how would you approach that? That's a good question. So maybe this kind of stuff could be applied like with a single shader. But yeah, so we can create these things as attributes, right? We can create these things as attributes. And that way we'll be able to render these glyphs like anywhere with a particular scale and whatnot. Yeah, should be pretty straightforward. Should be pretty straightforward. Alright. So I'm not sure how good of an idea, but yeah. Sodium Comrade, yes, exactly. Sodium Comrade accent. Initialize shaders. So to do all of that, we need to not only initialize Vertex Array object, right? We also need to start initializing Vertex Array buffers and Vertex attributes and so on and so forth, right? So we need to start initializing all of that stuff. We could probably put all of this stuff into a single structure that has a position, scale, the character, and the color, and then have an array of these sort of like glyphs, I suppose. Array of these glyphs, and then we can send all of that to the GPU, right? So let's create a structure for this thing. Type def struct, and how we're gonna call it? Let's call it glyph or something. I think that's gonna be all right. Vector f position, and then we're gonna have a scale. There we go. Actually, I have to do it like this. There we go. So then we're gonna have a character, but in case of a character, I want to actually send it as an integer, right? So So I suppose it's going to be aligned more or less correctly. So we have two floats in here, which aligns perfectly with 64 bits. Then here's another 64 bits. It's going to be actually CH, right? Another 64 bits. And then we're going to have a caller, which is basically 4 floats to 64 bits. Right, so maybe we need to introduce something like vector f. Right, so this is going to be the color. Okay, so I like that this texture is actually aligned perfectly without like any like padding or anything like that. Right, but we need to have a version of vector, like 4-dimensional version of the vector. So let me go to the linear algebra thingy in here and just copy paste this entire stuff. Right, so yeah. C doesn't have any templates, so what we have to do here, we just have to replace 2 with 4, and there you go. You don't need templates if you can just copy paste the code. Like, seriously, why would you need that? And another interesting thing is that I can also copy paste this chunk of code, right? So, and then I can select this entire thing and just query replace it one more time. There we go. So why do you need templates? You can literally copy paste the code. That is literally it. I didn't have 4-dimensional vectors, now I do have them. It's as simple as that. If this was C++, I'd had to go through some different places, add some like template and shit and all like that. No, I just copy pasted the code. So I keep telling the same thing over and over again. The reusable code is the code that you can just take and reuse. The copy pastable code is the most reusable code that you can have. Not the most abstract code with a lot of generics and an interface. No, it's the code that you can just copy paste to a different place. That's the truly reusable code. And this is a pretty reusable code in here. See, it's pretty good. Yeah. Copy pasting is the ultimate code reusing technique. To be fair, believe it or not, like I'm saying this as a half joke, but the entire industry is actually moving towards this kind of reusable code. GitHub Copilot is basically that. It's automating of copy-pasting the code. It's literally a tool for automating copy-pasting code. Like, this is not even a joke anymore. This is literally the truth. Right. So... So yeah, welcome to the future. All right. By the way, Copilot would be very, very useful for legacy code bases, right? Oh shit! Oh my god! Imagine training Copilot on a huge legacy code base and being able to replace the developers easy. Holy fucking shit! Oh my god, this is gonna be a shit show, everyone. This is gonna be absolute shit show. You won't believe how many people have like a pretty strong job security in enterprise just because they know a particular part of the legacy project and they become irreplaceable. Right. Basically, it doesn't even have anything to do with their programming abilities. So the only reason the company keeps them is because they have a specific knowledge on specific part. If you have tools like a Copilot that can train on your huge legacy code base, you won't need to keep these people anymore, and you're finally gonna have replaceable developers. Holy shit! I want to see that shit show. And I want to see those people actually rationalizing why rationalizing. How to say that? You got what I'm trying to say. Rationalizing why Copilot is bad or something. Oh my god, I absolutely fucking love it. Rationalizing. Yeah, rationalizing. Rationalizing. Yes, that's what I was trying to say. I was trying to say rationalizing. Right. Okay. So, what I was doing? Yeah, so here's the VIO, VBO, blah blah blah. Yumayo. And this wrote the C++ program to generate me a few hundred lines of VHDL. Now that's reusable code. Init buffers. I knew that you're gonna appreciate it, Sermon. So, yeah, let's actually put these glyphs into some sort of an array. Right, glyph, glyph, buffer, glyph, buffer, capacity. I'm gonna call it cap. And we're gonna define glyph buffer capacity. How many glyphs do we want to be able to render? Let's say that 1,000 glyphs is enough for everyone. I don't know. All right. So this actually has to be like a count or something. There we go. So, and I used to actually create a single vertex array buffer per vertex attribute, but I recently discovered that you can actually just create a single buffer and you can have several vertex attributes for a single buffer but with different offsets. Which is actually way more convenient in my opinion. I'm not sure about the performance implications of this kind of approach, but it's definitely more convenient, right? Because you just have like an array of structures and you just upload this array of structures to the GPU, and with different attributes you just sort of outline where to get the data and stuff like that. So I really like that. Yeah, I think it's pretty cool, if you know what I'm talking about. Okay, so let's generate some vertex buffer. GL, gen, vertex, is it just, I think it's just, it was just buffer, right, I think it was just buffer. Why int char? To align everything properly. To be fair, maybe it doesn't matter, but yeah. So I want to generate a single buffer in here, and we're gonna have GLU int VBO. Then we need to bind the buffer. GL bind buffer. Oh yeah, you have to specify, so it has to be array buffer. Do I have to also specify there? No, I don't have to specify array buffer in there. I don't think it's needed. So GL array buffer VBO. Your C knowledge are obsolete, by the way. Oops. Somebody doesn't know C. Somebody doesn't know C. All right, so let me. Okay, so we bound buffer. I don't remember what's next. Actually, kind of forgot. So bound the buffer. We need to provide the data there. Yeah. We need to provide the data. Yeah, so it has to be GL buffer data. GL buffer data. Oh shit! I didn't mean to do that. Why did it copy paste it to? Oh, okay. I just wanted to copy paste this shit. What the fuck? All right. So GL array buffer. GL array buffer. What is the size? In bytes of the buffer object new data store. Well, it's actually rather easy. Size of glyph buffer, right? Glyph buffer. So then we provide the data itself, right? So this is going to be a glyph buffer. And the usage is going to be, I think it's going to be dynamic draw, because we're going to be constantly updating this kind of stuff. So it's going to be dynamic draw. So after that, we need to start enabling different vertex attributes, but we need to keep track of different vertex attributes, if you know what I'm talking about. So we're going to create a vertex attribute per field in this structure. So what I like to do with vertex attributes, I like to create enumeration that lets me keep track of the vertex attributes. Right, so glyph, it's actually, yeah, enumeration, attr, right, so glyph attr, and then I can say something like glyph attr position, so which corresponds to the position attribute, like in here, then scale, then ch, and then color, right. And the first one is going to start at 0, and the rest of them are going to be incrementing, right? So they're going to be incrementing, and then we can say that we want to count them. So it's going to count glyph attr. So now we can even create a static array for each and individual glyph attribute. All right, so it's going to be something like. So the thing we want to have in here is actually to know the offsets for the fields in the glyph structure. So we can create something like static const, I don't remember in which order you have to put them, but the compiler will tell me, size t glyph attr offset, and the amount of these things is actually this, right? And after that you can do something like this. So boom. So it's quite important to know the offset inside of the structure for each individual attribute in here. So we're going to be using the offset of an operator named after a famous Russian C programmer. Haha! Alexander Offsetov. And this is how we're going to be using all of that. Offset of glyph pose size of, a line of, so 3 Russians, Offsetov, size of, and a line of 3 famous Russian C developers. Sorry. So it's gonna scale ch, and I suppose this one is gonna be cooler. Now, every time you program in C and you encounter any of these operators, you're gonna be thinking about that. So, because I surely do. Anyway, so this is basically what I wanted to have in here, right? So, and on top of that, we can do something like static assert, and we're going to say that the amount of glyphs in here that we expect is going to be 4, right? So it's quite important, because if you change the amount of glyphs in here, this code is not going to fail compiling. So it's quite important to assert this kind of stuff. So the amount of glyph attributes, vertex attributes, have changed. So some time ago, I suppose you're trying to say, you said that some life ago, it does feel like a different life, to be fair. You said that you participated in some competitive programming on school, not only in school, but also in uni. It depends from where you're from, right? So because in some English-speaking regions, uni is also considered a school, right? So, well, yeah. Did your team won some? No, we didn't. We're absolute papegas. We didn't won anything. All right, so the amount of glyph vertex attributes have changed, right? All right. All right, so that's pretty cool. And that way I will be able to actually just initialize all of the attributes in a loop, right? But I don't remember which function I have to use to do that, so it's gonna be interesting. docs.jl. Size. GL Vertex Vertex Array. Vertex Array. I remember. I'll have to look up in my game. So where is the shit? Something rewrite, and this is gonna be VAO. GL Vertex, yeah, GL Vertex attrib point. Okay, GL Vertex attrib point. That's what we need in here. So yeah, that's basically it. So let's go back to this thing and start initializing vertex attributes. So the index of the vertex, I suppose, believe it or not, you can essentially, yeah, so let's actually try to initialize a single attribute, right? So the single attribute is going to be glyph attribute position, right? So since this is an enumeration, right? So I basically have predefined IDs for all of the attributes, right? So I can just do it like that. So the size specifies the number of the components per generic vertex attribute, 1, 2, 3, or 4. Okay, so this one is rather interesting. I can specify position is actually 2, right? Because it's like a two-dimensional vector, right? So what's going to be the type? The type is going to be GL float, all right? GL float, and it's not going to be normalized. False. All right. So the stride is rather interesting. The stride is the size, right? Generates the byte offset between, specifies the byte offset between consecutive generic vertex attributes. If stride is 0, the generic vertex understood to be tightly packed in the array. Value is 0. So essentially here you provide the size of the glyph structure. Right, the size of the glyph structure. So it's going to be basically size of glyph, right? So, and a pointer is an offset within that structure. It's an offset within the structure, and you can essentially use something like offset of glyph position, and you also need to cast it to void star. Right, so here's an interesting thing. You need to copy-paste this 4 times for each individual attribute. And the reason why I create enumeration every time I make like attributes like that is that because I don't want to do that. I want to initialize all of the vertex attributes in a single loop. Right, so but to do that I need to know the ID, the amount of components, the type, and the offset. I already specified offset, right? So this is going to be glyph offsets. I already forgot the name. Yeah, glyph attribute offsets. So, but I also need the amount of components and type or something. So I think I'm going to introduce yet another structure in here. Struct glyph attribute definition, right? And we're going to just store things like offset, then GL vertex attribute. Components, size t comps, GL vertex, components size. I guess that's it, but you know, one of them is actually integer, so that means I also need to store the type. But the problem with the type is that if it's an integer, I have to use a completely different function in here. So you know what I'm thinking? What if the character, for the sake of convenience, is going to be float, right? Just for the sake of convenience. It doesn't really matter because the character is going to be just ASCII code. It doesn't really matter is going to be float or not. As a matter of fact, I already used that trick in ZZZWE, right? So there's a game that I wrote in WebGL, and it renders the text like that, and it actually passes the ASCII code to the GPU as a float. And you know why? Because in WebGL 1 there is no other way. There's literally no way to pass integers. So this kind of trick already works, so why not? Right? This is gonna make everything easier. So I don't see anything better than that. Float is too big, lol. You know what else too big? Anyway. Let me... So this is going to be a bunch of definitions in here. So glyph editor defs, right? So and this is going to be glyph attr def. Okay, so this one is going to be offset. And there we go. So the position, all right. Comps, bad, permanent. Okay, for the position is going to be 2. For the scale it's going to be 1. For the character is going to be 1, but for the color is going to be 4. Right. So that's basically everything that we have in here. So now that enables me to actually put this entire shit into the loop, right? So I can now do something like 4. Let's put it like that. Glyph attr. I think it's just attr. Yeah, I think attr. You start from 0, while attr is less than count glyph attr's attr. You're initializing the attr, then you take glyph attr defs, and here you have to provide the components. Okay, so and then you do the same thing but for the offset, right? There we go. So and we initialized all of the vertex attributes in a loop, all 4 of them. So we didn't copy paste like this kind of stuff 4 times. Right, we basically initialized that in a loop. And another thing I wanted to do, I think you also need to enable enable vertex array attribute. I think you have to do that. So and the index is basically the attr. Yep. attr, there we go. So that's basically how we do all that. Now I'm gonna try to compile this entire thing and see what's gonna happen. Thank you so much, Kodak. Okay, so this one is something like this, and I think it is compiling. Okay, so why I was even doing all of this kind of stuff? Right, imagine that I want to add a new attribute, right? So for instance, glyph attribute sound, whatever, it could be anything. So now if I try to compile the entire application, the application will fail with assertion. Right, it will fail with assertion, and I will have to be forced to add this entire thing, this sound, in here. But I also need to have the field. So while adding the sound in here, I will remember that I need to add structure to a field to the structure. Otherwise, this kind of thing is not going to even compile. Right, so that forces me to go here, and I'm going to add sound in here. And since down there, I have a loop, right, GL vertex. I don't have to modify this place, right, because this place takes the data about vertex attributes from those arrays above. So this is actually a very cool way. I don't know why a lot of tutorials don't show this kind of way of initializing attributes, because it's rather convenient, but it could be also confusing. So essentially, like, each individual attribute like becomes an enumeration, right? So you can add new attributes by adding an enumeration, and everything is checked at compile time. Right, so now you can basically remove this entire thing, right? So you can remove that, and I'm going to remove that. And then we can update the amount of attributes in here. So just managing the attributes becomes way easier, in my opinion. So I really like this trick with like enumerations and stuff like that. So, кого you fucking this, mate? Кого you fucking this? But we have to actually do some sort of instanced rendering, if you know what I'm talking about. Instanced rendering. Because here's the thing. If you want to draw a particular quad, you have to say that you want to draw 4 vertices, right? But all of these four vertices, they use the same texture, right? They use the same texture. So to be able to do this kind of stuff, we need instance rendering, where you can have sort of like a Cartesian product between different vertex attributes that you have, right? So basically, on the one axis, I have 4 vertices for a single quad. So this is the first axis. On the second axis, I have all of the possible characters. And then with the instance rendering, you can make the OpenGL perform this Cartesian product, where on the intersection between the current vertex and the current character, you can basically generate a new vertex and the colors and stuff like that. So, and unfortunately that requires a special OpenGL extension, but luckily we usually have it. It's a pretty common extension. We're gonna just use it. So I think that's precisely what we're gonna do right now. But before we do that, I want to kind of make a small break and refill my cup of tea, if you know what I'm talking about. I want to refill my cup of tea. So yeah, let's make some break. All right, so let's go ahead and implement the instance rendering, I suppose. So for the instance rendering, I remember we had to initialize a special extension, right? Because it's an extension. So this is how you detect Russians, by the way. I already talked about it. So just show them the Russify command, and if they get confused, they're Russians. Yeah, insta detected. So this is how you expose yourself. Congratulations. Yes. So draw instanced arrays, and I think I'm just gonna go ahead. Russian detected. Russian detected. Russian detected. Sorry. So that's the extensions that we have to enable in here. Extensions. All right. So in here it's going to be actually printf. Yep. And maybe on top of that, we're going to be doing. I said exit one. There we go. So let's see if all of these extensions are available, right? So let's recompile this thing, and it doesn't even compile because I'm bebega. I'm a huge bebega. Okay. So if I try to run this entire thing, it is running, and apparently it is working. Yeah, bebega. bebega. I don't remember, like, what's the function? GL vertex attrib divisor something? Yeah, I think it's something like divisor. Yes. Кого здесь? Yeah. So basically, specify the index and specify the number of instances that will pass between updates of the generic attributes. So since, as already said, we have a Cartesian product between two sort of vertex attributes, the vertex of the quad that we're trying to render and each character, right? Because we want to render a quad per character. That's what we're doing, a quad per character. So that means the divisor for each individual attribute is going to be 1. Right, it's going to be a single instance. If I understand that correctly. I don't know yet. We'll see. So that means I'm going to go to the GL vertex, and in here I'm just set this like that. And this one is going to be just 1. There we go. The divisor. And another thing that we're going to use, instead of GL draw array, we're going to use GL draw array instanced. GL draw GL instanced GL instanced Yeah, that's what I wanted to do, but I couldn't find it because I'm Pepega yet again. So you have a mode, you have a first, and this is the count of vertices that you want to render, and this is the count of instances. Right, so that's precisely what we need to do. Where is the event loop? Right, so instead of this thing, we're using GL triangle strip, then 0, then 4, and the amount of instances, since we're rendering all of the glyphs, right, so that means the amount of instances is glyph buffer count, right, so each glyph is essentially an instance, if I understand things correctly. Right. Each glyph is an instance. Alright, so let's put it like this. And now in the we essentially sent the glyphs into the GPU. That's what we essentially did. We just send them to the GPU. Now we need to receive them on the GPU part in the shader. So let's go into the shader. So here we're gonna have a vertex, and if I remember correctly, I need to remember the syntax. Something rewrite, assets, shaders, and we have a vertex shader, so something like triangle screen. Yeah, this is how we do that. Layout, location, and stuff like that. So the location should be equal to the ID of the vertex attribute. Glyph. Yeah. So here are different IDs, and these IDs correspond to the location in the layout. Right, 0 has to be a position. Right, so this is the position. So we basically have to go through all of these things, and for each of these things create a separate layout. Unfortunately, we kind of like live in a territory where the compiler will check if we didn't forget to add add all the necessary code for the attributes. But this is like specifics of the OpenGL. There's nothing we can do about that. Unfortunately, there's no connection between this part of the code and this part of the code at compile time. Literally zero connection, unless you implement a special parser of the shaders that checks that you put all of these things in here, but it's too much work. So we're not going to do that. So here's the scale, and scale is going to be just a float like this. So basically this is how we send in all of that, and this is how we receive in all of that. So the next location is float character sh, and then we also accept the color, and the color is a 4-dimensional vector. There we go. So we accepted all of the attributes in here. Right. Accepting all of the attributes in here. So in the position is going to be sort of like in the screen coordinates, but the screen coordinates are going to be the following. So if your resolution is 800 by 600, so the coordinates are going to be like following. So you have a 0 in here, and here you're going to have plus 400. So let's actually type it properly. And minus 400, minus 300, plus 300. So you see what I mean? Yeah, something like this. All right. Okay. So, and GL vertex ID is going to be basically cycling through 4 vertices. So that means we can quite easily just keep using this thing, right? But on top of that, I think I'm going to be actually just inlining this entire stuff. Right, so I don't need this kind of thing. So here's the UV coordinate. So we have a quad, which is 0, 1, 0, 1. What we want to do, essentially, we want to map it to a shape of the glyph. So the shape of the glyph is predefined right now, so you can sort of find it in here. So font H, it's this amount of pixels. Actually, I think we can even just copy paste this entire thing inside here. So this is like a font width, font height, amount of columns, amount of rows, and yeah, so we know precisely font character width and font character height. Right, so with all of that, we'll be able to just take UV and multiply it by character size, right? And the character size in this particular case is going to be something like vec2 font character width, which is float, and font character height, which is going to be float as well. There we go. So basically, by multiplying UV quad by the character size, we make it, we give it a shape of the character, right? So now we need to scale this entire thing correspondingly, right? We need to scale it, and the scale of the glyph is known. It's actually sent along with the glyph. So this is going to be something like this, right? And there we go. We got a quad of a particular size, right? Of the right size. We calculated the right shape and size of the glyph, right? So this gave us the shape, and this gave us the size that we want. So now we need to locate it in a correct position, right? So we need to locate it in a correct position. So for that, we add position. So that's pretty much it. So interestingly enough, like we don't need CH and color in here, but I just keep it just in case. All right. And this is essentially the position that we need to send to the fragment shader. But this is a position in a screen coordinates, right? It's a position in the screen coordinates, but we need to map it into the NDS, normalized device coordinate, NDC, not NDS, NDC. So let's create some sort of a function, I suppose, to do that. Project point, right? So this one is going to accept thing in the screen coordinates and return in NDC, right? So we're gonna put it like that. Let me actually skip this song. It's kind of annoying, not gonna lie. Boom. There we go. So and it's not implemented yet. So I'm gonna just return it like this. So project point, like this, project point. And I suppose that's basically the GL position that we wanted to have in here. And we also have UV. So that should be it, I think. That's pretty much it. So the only thing we need to implement in here is the project point. So if you have this sort of thing somewhere here, how would you project it from minus half of the width to plus half of the width to -1 and 1? Well, I suppose you can just take, like, imagine that this is an X, right? And you can just divide it by half of the width, right? So, and that will automatically map it from 0 to 1, right? But because you're dividing by a fraction, you can sort of like do 2x divided by w, right? So that's basically how you map x from the screen coordinates to the normalized device coordinates, right? That's basically it. I wonder if I can do something like 2. I multiply this stuff by 2, and then I can just divide it by the resolution, by the whole resolution. So, but we don't have a resolution, so we have to pass that resolution somehow, probably via the uniform. So it's going to be vector2 resolution. There we go. So that's basically the entire mapping. And this is the entire shader that actually positions everything accordingly. I wonder if we'll be able to actually get rid of these two things and only have them in the fragment shader. I think this should be a thing, right? So basically here we only have position and scale, right? Because we don't care about anything else in this specific shader. But here we have specific character and the color. Using the specific character, we're going to be looking up the glyph texture, and using specific color, we're going to be actually mixing it in. What if you change the sign? Which sign? We have a pretty cool emote. It's called kek sign. Look. Are you talking about this? I think you were talking about this sign. From -1, you don't need to do that actually, I think. If your x is negative, right, so if your x is negative, right, so essentially what you do, you divide negative, you multiply this thing by 2, which makes it still negative, and then you divide it by w, which still keeps it negative, so the sign is actually preserved, if that's what you mean, so it's kind of the point. So none of this stuff actually get rid of the sign, so that's the beauty of this thing. You can put a vertex input into pixel share. Yeah, you can. So essentially you declare something as out, and on the fragment side you declare the same thing as in. I think you can always also associate some sort of like location in here, so you can name them even differently or something like that, but I'm not really proficient in GLSL, so I don't know for sure, so this is something that I have to look up. But the only thing I know is that if you name them the same way, or maybe in the same order, they're gonna be fine, and they will actually send the information between them. Yeah. So we're gonna be doing in here. I think I need to already test how this entire stuff will work. So, and to do that, I'm going to just take this thing and simply put a red color in there, just to be able to see that something is happening. Right, so, and we're gonna try to render that. So, but to be able to render that, we need to put the corresponding glyphs accordingly, if you know what I'm talking about. So, what I'm thinking is that we need some sort of a function. So, a render text. And the render text is going to take the characters, right? And the place in which you wanna render all of that. Let's actually call it the GL render text. So, and this is the position, and then we need to have the scale. We need to have the scale, and maybe also the color. Why not? We might also have a color in here. So, and what we need to do in here is basically populate all of the glyphs and stuff. So to be able to easily populate the glyphs, let's implement a function glyph buffer push, which accepts a single glyph, right, and pushes it into the buffer. It's as simple as that, but also it range checks, it actually overflow checks, right? If the glyph buffer count is less than glyph buffer capacity, so right, only then you'll be able to do that, right? So, hello Frog. It's not that hardcore, to be fair, so I don't know, Probot is actually doing stuff that is more hardcore than this kind of stuff. So Frog actually asks, why do you always like code something very hardcore? In a very broken Russian, by the way. So alright. So because he's fucking cool. So he asked why everyone actually like always sends to Probot. So the answer why everyone always sends other people to Probot when it comes to computer graphics is because he's a very cool demo scener. So he knows a lot about this kind of stuff. At least I think so. I don't really know because I'm not a computer graphics guy. Alright, so we want to append this thing in here. Right. So I guess that's it, right? So let's iterate through the text. Text size ++I, and so let's construct the glyph. Glyph. So this is a glyph definition, and here's the actual glyph. So we need to set the position, right? But the position is going to be basically position. So Frog says that Probot streams are boring. This is because you don't understand anything. Oh, sorry to tell you that, but the streams are usually boring when you don't understand what's going on. So he's that hardcore. So yeah, he's that hardcore. All right. So this is the position, and then we'll need to construct this thing like that. I multiplied by font character width scale, and we're not gonna actually update maybe y coordinates, so I'm gonna just keep it like this. So it's gonna be, so I'm thinking maybe it would make sense to do something like vec to f character size, right? Vec to f. So I'm doing some layouting on CPU for some reason. Maybe this is something that I should take as a red flag, but I'm not sure. To be fair, I'm not sure. So this is a character size, and then what I'm taking is vector to f multiply character size by vector to fs, actually just to f, I 0. Right. And I need to make yet another multiplication, and I wish we had a function mul that actually accepts 3 arguments. I wish we had something like that. Maybe I'm gonna create such function, like mul3. How many of them do you actually would you actually need? That's a good question. I don't know, to be fair. So this is gonna be mul. What about mul3? Let's see. Mul3 is essentially vec2 fc, and we can actually implement it in terms of the mul, right? So this one is going to be vec2 f mul ab vec2 f mul c. There we go. So this is how it's going to be, and in here I'm going to just do 3. So we multiply this thing like that, and then we also multiply this stuff by the scale. There we go. So you have a position, you have some other stuff, and there is the, yeah, this is the final result, I suppose. Okay, cool. So this is only the position, but the scale is already given, so we don't have to worry about it too much. Scale. So the character now. Character is going to be very interesting. So you take text I, you literally have a char, and you cast this mother flipper to float. Sorry. Yeah, that's how we're going to be sending it to the GPU. So, and once we have a glyph, right, we can push that glyph into the buffer. So glyph buffer push. There we go. We just pushed it into the buffer. Isn't that amazing? So this basically, like, yeah, renders the text, but it just appends the glyphs into the buffer. We need yet another function that will let us synchronize the glyph buffer with GPU. So we pushed a bunch of stuff in there, But that's not enough, right? That's not enough. You also need to synchronize this thing. So let's implement a function, something like glyph buffer sync, right? And as far as I know, to send the data to the GPU, you have to use something like GL buffer subdata, right? Subdata. Yeah, that updates the buffer on the GPU. Mods. Thank you so much. Thank you. GL buffer, GL array buffer, I think. GL array buffer. So the offset, as far as I know, replacement will begin. Oh, so we actually want to replace everything starting from 0. And the amount of stuff we want to replace is in fact equal to glyph buffer count multiplied by the size of a single glyph, right? Size of the glyph. Right, and then we provide the glyphs themselves, glyph buffer, right? So this is a glyph buffer. There we go. All right, so that's how we're gonna be synchronizing this stuff. On top of that, I think, oh shit, but it's already bound, right? Yeah, we only have one vertex buffer and it's already bound, so there's no need to do this kind of stuff. Okay, so now if I try to, yeah, so glyph GL render text. So what I'm trying to do in here, I'm gonna try to do a hello world, maybe some sort of a text. So strlen text const char text is gonna be hello world. So this is the hello world situation. So where this kind of stuff is going to be located, let's say this is going to be located at 0. The scale is going to be 10, and the color, I don't know, let's create some sort of color like this, vect 4f color, 4f, let's use red. There we go, so here's the color. So we render the text and then glyph buffer sync, right? So we want to synchronize this kind of stuff. Right, so we synchronized the glyph buffer. So, yep, that should be it. So as far as I know, maybe in the Fragment Shader, we can literally use the color that was sent from the GPU. I think that would be a pretty good approach. Okay, so let me recompile everything one more time, just in case. And it doesn't even compile, of course. Too many arguments, okay. la.h, yeah, back to fc. Okay, vec4f, too many arguments, okay. So, oh yeah, sc, float x, float z, float w, okay. So this is because I copy-pasted, but I mean, it's actually not that difficult to fix. Replace y, z, and the same goes for w. Alright, so is it gonna compile now? Hopefully, and it doesn't compile because... oh, the vector is... okay, so... that's what you get for copy-pasting code! Well, I mean, the compiler tells us the problems in here, so it's not that hard to fix. Oh shit, okay, so... fuck. I didn't think about this kind of stuff. But again, compiler told us, so it doesn't matter. Don't copy paste, yeah. Don't copy paste, otherwise compiler will tell you all of the places where you need to make the fixes, right? So, and you don't want the compiler to tell you anything, you want your program to silently fail in production, of course, yes, don't copy paste your code. Yeah. So also I just noticed, so this is actually kind of bad. And this is something that the compiler won't tell you, by the way. But maybe it could tell you. because this is kind of, well, it's not really that sus, to be fair. Right. I think there are some linters that can actually tell you this kind of mistake, right? Okay. And it seems to be working. So let me double check that I didn't do any significant fucky-wucky or any, you know, sort of oopsie-doopsie. And let's just try to run it. And the fragment, yeah, the vertex shader actually is failing at the 25. Okay, so oh, this is because I have to do vector 4, of course. So this one's been 0, 1. There we go. And is it gonna work? So now fragment shader is failing. Let's take a look at the fragment. So this is going to be the compilation of our nation. Hey! Sorry. 6 layout. Shader input explicit location require separate shader object extension. Explicit. But I mean, it works in a vertex shader, but not in a fragment one. That is very interesting. So this is the fragment one, this is the vertex one. So what if I put something like this in here? So it will also fail. Yeah, okay. So I suppose what we'll have to do in here is basically pass the information to the fragment shader from the vertex shader. It's getting really annoying. I'm getting really annoyed. So, let me see. Let's put this like that. So this is going to be UV, and we can do something like out float glyph sh vec4 glyph caller. So this is what we're going to have in here. Glyph ch. Okay, so that means here I can just do something like glyph caller. Okay, so it worked. Nice. But we couldn't see anything, which is kind of sus in my opinion. And we don't even know why, because it's a freaking classic. Freaking classic. Ugh. Okay, so what if I essentially set this thing in here, like a very specific color? So I also probably need to, I'm just gonna just in case rebuild everything in here, you know? Okay. So maybe we want to step through in a debugger just to see if everything is filled correctly, specifically the text and stuff like that. Right. So this is going to be something like this, and it's TE, GDB TE. There we go. And we're going to break on main C311. Right. So this is going to be run. And let's take a look. So we can try to print the glyph buffer count. Right, we have 0 of them. And after that, if I try to print the glyph count, we have 12 of them. And we can take a look at the glyph buffer. So there's a lot of different things in here, and that looks all right to me. Okay. So here are all of the glyphs in the memory, right? And we're about to send them to the GPU. Okay, so buffer subdata, I suppose I'm sending everything in there. Okay, so this is going to be that. GL array buffer. Okay, so I don't see any problems in here, to be fair. What kind of events do we receive in there? That was really sus. I don't know what was that. Huh. That didn't help. So what if I'm gonna try to render only a single glyph in there? It could be that the buffers are bound. All of the buffers are bound correctly, so everything is bound in here. Then I render everything and synchronize everything. Yeah. I would expect maybe the scale is not particularly correct. Maybe the scale is not right. Render doc. Maybe. So, but maybe not. Because I still haven't figured out how to use render doc, so probably not gonna use it. Alright, so what if I just use GL position, oh my god, as UV, so here is the UV, and that should render at least something, right? So we can just use it like that. Oh my god, this suspense. 30, oh yeah, this has to be vector 4, 0, 1. Alright, I can just use something like this. Okay, so the data is actually set correctly, so it's something within the shader. So if I set the color of the glyph to something like 1, right, and I try to recompile. Okay, so now I know like roughly the place where we can start bisecting for the problem. So I think it's somewhere inside of the vertex shader, right? So there's some weird stuff in here. Okay, so yet again we have this kind of thing. Font character width, font width, font height, and everything all right. So I take the UV, multiply by the character size, then by the scale. Oh, you know what? I think I know what the hell is going on. Oh, no, not really. No, not really. Okay. So what if I actually do something like this? Right, so maybe the problem is in project. I think the problem is in project. Where's the vert? Okay, this one is rather interesting. So it is in fact very, very big. This one is truly sus. This one is truly sus. So if I multiply it by 2 and then... Well, obviously, I never actually set the resolution. Yes, okay, so that's the problem. I just never set the resolution. Alright, time, actually, resolution uniform. GL get uniform location, program resolution. There we go. So here's what we have in here. And I suppose I can set the resolution only once, right? There's no reason to set it multiple times. But what's the resolution? I guess, do we have like a screen width? I think we do. Yeah, screen. Yeah, there we go. So GL uniform to F resolution uniform. So just in case if the resolution changes, we're going to be updating it in here. So it's going to be set to screen width. So it's already like a literal, so it doesn't matter. So this one's going to be height, and that's pretty much it. So yep, and I need to recompile this entire thing. So it's gonna be TE, and in the Vertex Shader, by the way, I don't apply the project. Okay, so let's project the point, finally, hopefully, and finally, there we go. So here is the line. Here is the line. So we can actually set maybe the scale to something else. So GL render text. So the scale is going to be 5, so I just want to fit the whole line in on the screen. But again, we'll have to. My God. It's actually too much, so. But I mean, it's alright. Okay, whatever. Now, what we need to do, we need to actually look up the glyph in a font sprite sheet. In a font sprite sheet. So we know the CH. And we just need to calculate the corresponding coordinates. So vert, it's going to be something like this. We probably need this kind of stuff. I think it's quite important. At least the the amount of rows and columns. Yeah, this one. I think this one is kind of important. So amount of rows and columns. But the font char width and font char height. So yeah, in our case, width and height are just equal to 1 because it's a UV coordinates, right? Right. So this one is gonna be essentially that. There we go. So we have columns and rows, and there we go. You have basically char width and char height, which you can easily look up. So we're gonna do the following thing. If glyph ch is outside of the ASCII printable range, right? So we can do something like this. ASCII. So the printable range starts from 32, right? As far as I know. Yeah, something like 32. It starts with a space, right? So it has to be something like this. 32. Right. So it's gonna be ch less, and it ends at 127. So essentially, if this thing is not within that range, what we're gonna be doing, we're gonna be setting it to, we're gonna replace it with something. For example, a question mark. I like to replace this kind of stuff with question mark. So where is the question mark? Here it is. It's going to be 63, not even 69. Right, so it's going to be glyph ch, and I'm not really sure if it's going to be like a right thing to do, but whatever. So we're going to have an index, glyph ch. We're going to subtract 32 in here, right? Yep. So here's the index, and that should give us some sort of a row. To be fair, You know what? I think I'm gonna actually convert it to integer, just to be safe. Right, so it's gonna be glyph ch, and yeah, literally convert it to an integer. So that way we don't have to do like this floating point comparison or anything like that. I think it's gonna be way better. So this one ch is gonna be 63, and the index is gonna be ch minus 32. So for this, for all of this like a magical constants, we can have also this kind of stuff. ASCII display low 32, ASCII display high, right, 127. Right, we're basically like working with the ASCII codes on the shader. That's what we're doing. Right, so that's actually pretty cool. All right, so ASCII high. So if we, well, this one, it has to be actually equal, right? So it has to be equal to this kind of stuff. Okay, so we have ch, and this is the index. So now we need to work with the rows and columns and some other shit. So the row, or the column, is going to be what? Index mod of font calls. Okay, so the row is going to be division by this thing. So now we have a row and column. So on top of that, we need to multiply it by, yeah, so if we convert this stuff to this thing, font character width and height, there we go. So this one is going to be x, y, and this becomes float. All right, so you have x and y. But this is only a position, right? This is only a position. Interestingly, right, now we need to do what? We need to turn it into a vector, and we need to add the essentially another vector of this of the entire size, right? Font character width. Right, font character width and font character height. Right, but depending on the UV coordinates, we have to actually zero out some of the components in here. So that means we're gonna multiply by UV, and that already gives us the basically the textile, I suppose, right? So which we can put into the texture, and there we go. We grab the color, the corresponding color that is needed in here. So, but I'm not sure if it's gonna work properly because like UV coordinates and shit. So it could be upside down. So we'll have to debug that at some point. But I've already done it before, so it shouldn't actually, you know, cause any problems. So we can actually extract this entire vector into like a separate thing. Nah, but maybe not. All right. So let me see if it's gonna do anything. Okay, so it kind of works, but it's upside down. If you know what I'm talking about. It's kind of upside down. I wonder if we can... okay, so let's actually save it somewhere in here. So this is gonna be like t, right? I'm getting a little bit tired, especially with the very backseaty chat, so it's really exhaustive. All right. Yeah, so we just need to actually flip it horizontally. There's also kind of weird thing in here. I'm not sure what exactly causes that, but we can investigate that. Maybe if we flip everything around, maybe it's not going to be a problem anymore. But overall, I think it's working fine. more or less. So also we probably want to multiply by the glyph color, right? So we want to be able to multiply by glyph color, and this should be red now, right? Oh, green. I mean, we actually set the color to green in the original thing, right? So we can set it to red. Actually, each individual like glyph can be a separate thing. Yeah. So this is the red. Okay, so this is the font Frag. So I need to visualize that in my brain super quick. So let me see. 0, 1, 0, 1, right? So, and essentially, because of that, right, so it starts somewhere here, and we are basically incrementing it like this, right? So that means the size. So remember, I actually implemented the flipping in my game, so maybe I can steal some idea from there, because my brain always like kind of fails to understand how it's done. So this is ABB, maybe it's math, yeah. ABB, something like flip. Flip vertically, right? So essentially what we're doing here... Oh, okay, so that makes sense. So you... yeah. You take the position and your size becomes that. Okay, so that makes sense. That becomes that. So I'm gonna actually put it in here. So because of that, maybe the position is gonna be vector to position x, y plus font character height. So this is going to be this thing, and then we're going to have the size, which is essentially vector 2 font character width, font character height. There we go. And that way I will be able to do something like position and size. Well, this one has to be actually negative, of course. Yeah, something like this. So now that makes sense, actually. That makes sense. So do that. Okay. And let me restart it. Hopefully that will do something. And it worked. So it's a little bit like really weirdly offset. I'm not sure what exactly causes that. But yeah. So maybe because this is because I have to like calculate this kind of stuff in... Yeah, it feels like I have to do that in here. Font calls. Font char. Char width. Well, this is correct. Oh yeah, overall it kind of works, I guess. And you can also, of course, animate this kind of stuff, right? So, so sign of time, preprocessor and GPU. Well, and it's not really on GPU. I'm pretty sure it's stripped off. So this one is plus 1. This is going to be plus 1 divided by 2. So this could be cosine, and this could be sine yet again. Yeah, because why not? I don't know why I'm recompiling the whole program. And this one, yeah, it could be like this. Yeah, it can change its color, but it still has this weird artifact, which I'm not sure what's causing that. Okay. Sus. That is truly sus. So it could be because, well, yeah, in reality, I think I know kind of what's going on. Yeah, I think I know. Because the sizes has to be computed in integer. Yeah, I think I even know how to fix that. Yeah. So this has to be like this, and we need to create like a second version of that, which is basically UV. Right, so this is going to be UV, where we convert both of them, so width and font width to the float, and that gives us the ratio in here. Right, and this one is essentially height. There we go. And if I try to run this entire thing, well, something went horribly wrong. I wonder what. Font width, all of that has to be... Oh yeah, because I have to use that now. Yeah. So if I want to be able to have that, I have to use it. So UV, and all of that is UV, all of that is UV, and I fixed it. Yeah. So I know it. Now it's clean. Now it's perfectly clean. All right, that's pretty cool. And I guess we implemented this simple text renderer on the GPU, roughly. So the things are not positioned properly on the GPU. It would be kind of interesting to also compute position, right? You know what I'm talking about? So in here, GL render text, we do all of the layouting, right, for the Vertex Shader. It would be kind of interesting to do that on the Vertex Shader, if you know what I'm talking about. So, and to know how to do that on the Vertex Shader, I suppose, yeah, you can only render it by line. Huh. So, along with the... Yeah, so essentially you'll be only able to render this kind of stuff in a tile setting, right? So you only have a tile setting. And instead of position, which is like vec2f, which is the absolute position, you would have something like the cell position within the render. Yeah, it will be, yeah. So calculating all of that on the Vertex Shader would mean that you will have a pretty like strict tile render or something like that. Which is not that difficult to implement, but it will require like a little bit of a refactoring in here. But I think that will be rather interesting, because that will simplify like a lot of these things, right? Anyway, so I think I'm going to do the following thing. I'm going to comment out OpenGL renderer, all right, and that will mean that the entire thing is going to fall back to the SDL renderer. Right, so the OpenGL renderer is not particularly finished yet, so that's why we're not going to release it right away. Right, so this is how the SDL renderer looks like. Right, so this is what we're trying to port into OpenGL. Right, but the OpenGL renderer is not really finished yet. Right, so we're in the middle of implementing it. Right. So this is basically what we're working with. Right, we want to be able to do this kind of stuff, but in OpenGL. And we're already getting closer there, as you can see, we're already getting closer. So it is actually fun, so it is super cool. You can theoretically open the source code of the text editor itself in the text editor, so this is how it looks like. Right, but all of that is rendered with the SDL renderer, not OpenGL. Once we implement OpenGL, we're going to have actually a lot of cool things with shaders and whatnot. Right, Inception. Yeah, the text editor is self-hosted. You can edit the text editor within the text editor itself. Right, anyway, so let's actually go ahead and commit all of that. So essentially, to have an OpenGL renderer, just to test the OpenGL renderer, you need to uncomment this define, right? So, and it will replace the current renderer. So quick and rough implementation of the OpenGL renderer, right? So I'm gonna push that right into the repo. All right, so, and I don't think it's gonna fail on any of the operating system right now because the OpenGL renderer is not built anyway, right? So yeah, we need to finish it first. Yeah, but unfortunately, we're gonna do that next time. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all on the next stream. I don't know when's gonna be the next stream, maybe tomorrow, maybe the day after tomorrow, it just depends. Check out all of the links in the description if you're watching it on YouTube. If you're watching it on Twitch, check out the YouTube channel where I upload the recordings of the streams. And I gotta go, boys and girls, I gotta go. Thanks everyone for watching, love you all. Mwah.